Okay. Good afternoon, Miami. Buenas tardes. My name is Erik Rasmussen, and I'm here today to talk to you about a relatively new framework you might have heard of called Solid.js. First, a little bit about myself. React developer is a large part of my identity. I've been building web apps in React for literally all 10 years, ever since they open sourced it. And I was such an early adopter that I ran into some of its rough edges and ended up writing some popular open source libraries, as she mentioned, like Redux Form and React Final Form, that are still pretty popular today. What I am not, however, is a Solid developer. I'm just a React developer that has learned a little bit of Solid, and in the same way that I think I would be a bad teacher of beginner React because I've internalized so much of the complexities, I think my position as a Solid novice gives me some insight into talking about Solid, especially to an audience of React developers. So first we have to go back to computer science class briefly and talk about some terminology. Imperative programming is where we tell the computer how to accomplish a task. So back in the ye olde jQuery days, we would have to do something like this. When the document is ready, find the button, register a click listener on the button, so that when that is clicked, we find the greeting element, and then we add a class to that element. And if we wanted to remove the class on the next click, well, you'd have to code that yourself. It's just exhausting. Luckily, then came declarative programming. And declarative programming is where you tell the computer what to show based on the internal state of the application. This is what React gave us. So in React, you've got a bit of state, and you declare that on this button, when this is clicked, you're going to change part of that state, and then you declare on the div that you want to change the class on what to do based on that state. This is super powerful. Now, we're going to talk about a subset of declarative programming called reactive programming. Reactive programming is a declarative programming paradigm built on data-centric event emitters. Now, what the heck does that mean? Before we get there, I want to quickly go over the example on the reactive programming Wikipedia page. They contrast it to imperative programming like this. In imperative programming, you define some variables, they have their values, you can define another variable, you're doing some calculation with those values, and that's totally normal. But if you change one of the prior variables, obviously the sum isn't going to change because you haven't run that calculation again. This is like the way computers work, right? But what if it could? What if it did change? That is the promise of reactive programming. So how can we do that just in plain JavaScript? Well, if rather than storing the values for these variables, they were actually functions that emitted those values, then when we define our sum, what we have inside there are closures to these functions. And if we redefine one of those prior variables, it works because literally calling the sum function is running the calculation again. This is due to the magic of closures. So how do we get from here to data emitting events? Well, this brings us to signals. This word has been flying around a lot lately, even though it's nothing new. What even is a signal? A signal is a value that remembers everyone that reads it and then informs them when the value changes. I couldn't find an authority figure to quote, so just take it from me. The way signals work in Solid is with a create signal function. Now, to a React developer, this should look extremely familiar because it looks just like useState. You give it a default value, and then you get a tuple of your value and your setter. And then you can print out the value, you can set the value, and you can read the value again. However, you may notice something a little bit different about this code. In the same way that we had to replace our values with functions before, our value here is an actual function. And as I've been learning Solid, I've noticed there's several ways that you can shoot yourself in the foot. So I am labeling this foot gun number 1. Signal values are getter functions. You must remember this. So these value calls here are what get the value. Now, you might think, well, you could just rename it to a getValue function, but This is not the standard in the solid community, and in practice, it really is just fine reasoning about them as if they were values themselves. You just have to remember to call them as functions when you want the actual value. Okay, derived values. Derived signals are, you can just create a function that consumes one of your signals, and voila, you have a read-only signal. This double is now a signal. If we create a function to increment the count, and we print these out, then you can see that the double is changing as well as the count. Now, the place you've most likely experienced this sort of reactivity is with spreadsheets. The cool thing about spreadsheets is you can define a bunch of values, and then you can define special formula cells that use those values. And when the values that they depend on change, you don't have to go back and click recalculate that cell. It automatically notices and redoes it. So talking about React and reactive programming, I need to address the elephant in the room. And that is that some people are fond of saying, but React isn't reactive. And technically this is true. React is not reactive programming because React decouples the events that change data from the component updates via scheduler. So when you call setState, it doesn't immediately cause the update. It puts that component in a, hey, this needs to be updated eventually queue. However, this doesn't matter. Stop calling it that. Stop making this joke. It's dumb. So, pop quiz. Is this a React component or a solid component? Well, the answer is sort of both, because this is how similar the React and Solid API is. Both React and Solid divide UI into components. Components are just functions. Components take props, and they output JSX. So let's look at the ever ubiquitous counter example. So you got a button on the page, and we're going to increment a counter on the page. So in React, we use useState, and in Solid, we use createSignal. We display the count, and on our button, we have a set count that will update our count. Now, expert React devs in the room will dislike how I've implemented this here because the way React works, where you just get put into a this needs to be updated queue, you can't guarantee that the count that you will have re-rendered and the count is what it should be. You can press the button fast enough that you can mess that up, which is why React has this functional version of the setter where it will give you the previous and you just need to give it the next. Well, turns out Solid has this as well. So these functions are literally identical now. So while this code looks very identical, what's happening under the hood is totally different. And I'll get into that in a moment. So what if we want our counter to update every second? Well, in React, we get rid of the button, and we use everyone's favorite hook. And we set an interval, and we have to remember to clear the interval. And, oh, wait, we forgot the dependency array. But again, React developers will notice that this is the wrong way to implement this. In fact, this is not a bad interview question to see if people know React, because whenever the count changes, it's going to clear the interval and then set it again, and that's not what we want. So we use that functional setter syntax, and then we don't have anything in our dependency array. So how do we do this in Solid? Well, we're going to get rid of our button. And hold on, everyone. This is not a drill. We set interval to update our count. And then we have an onCleanup function that's going to clear our interval. Now, if you're like me, the first time you saw this syntax, you are like, what the hell is going on here? You can't do this in your component. What is even happening here? And this brings me to the most mind-blowing thing about Solid for React developers, which I'm labeling footgun number 2. The function component is only called once. I know. I was just same way you are. Let me see if I can explain how this works. So you know how in React, there's sort of like this imaginary line through the return keyword where above the line is where you put your hooks, and below the line is your JSX output. Well, in Solid, there's the same sort of thing, except above the line is stuff that's going to run when the component mounts, and below is the JSX. And it's really important to remember that you can't assume that anything before the return is going to happen on every render. In fact, the word render doesn't really make sense in Solid. And that's because they're fundamentally different. React is a just JavaScript framework that re-renders to the virtual DOM every time data changes and performs a diff to know which DOM elements to update. Whereas Solid is not just JavaScript. It's a compiled template language that remembers which DOM elements depend on which state. So what does that look like? So when this component mounts, Solid notices that the h1 depends on the count signal. And so whenever the count signal is updated, Solid knows to update only the h1 in the DOM. This is how Solid gets away without having a virtual DOM and is very fast. So now that we know this, what's wrong with this code? Well, this line here is because this is only happening once, the count is always going to be 0, and your double count is always going to be 0. And therefore, if you output a value in your JSX that's not a signal, it'll never know how to update, right? Because the way we communicate to Solid when this needs to update is by using a signal, not just a value. And I'm going to call this footnote number 3, that you should only use signals in your JSX, not values, because they can update. And never try and get the value from a signal before you start in your JSX. So let's talk about props. In React, this is a pretty common pattern where you destructure your props to make your JSX look a lot cleaner, either on the first line of your component or in the function definition itself. And you'd think, well, this should be able to work just fine in Solid as well, but you would be wrong. Because props in Solid are a little bit magical, because props are secret signals hidden in getters inside the props object. So this props object really looks something like this, where it's just these read-only getters that JavaScript has. So now that you know this, this line is a big red flag, because we are breaking footgun number 3. We are getting the value of a signal before our JSX. And I'm going to go ahead and hoist this to its own footgun of never destructure props. So now that we know this, the way that you fix this is you just use the props object in your JSX, and you get rid of the destructuring. But what about default props? Because the modern way in React to do default props is to do it when you're doing the destructuring. So if you can't do destructuring, how do you do that? Well, Solid provides a utility function called merge props, where you can give some default values, and it will create an object that is still reactive like that, that's still based on signals. So then you just use that in your JSX, and you're good to go. OK, let's talk about some common hooks in React. I'm going to go on the record and say that useEffect is the single most dangerous hook in React. And that's because there's so many ways you can mess that up in React. And so much of what we do with useEffect is just stuff that we want to happen on mount. We're adding event listeners, we're fetching data, we're subscribing to something. And all of that you can just do before the return in Solid. But sometimes you need an effect where you need to do something when data changes. And for that, we have a function called createEffect in Solid. So how do we do an effect in React? Well, say we want to just like print out something to the console when the count changes. We're going to use everyone's favorite hook, and well, we can't forget the dependency array. And in Solid, all we do is we use createEffect, and wait, we can't forget the dependency array. No, sorry, never mind. No dependency array needed because of the way signals work, Solid knows that in this create effect, that function depends on the count signal. So anytime the count changes, it knows to rerun that effect. So what about useMemo? It's usually used for doing expensive calculations. In React, we just call useMemo. Forgot the dependency array. It's very important. And in Solid, you'd think that this might be a way to do it, but this line has a problem. What's the problem? Well, we're getting a value of a signal, the props.value, before the JSX. So what we can do is we can wrap that in a function that turns it into a derived signal, and then we can just use that. However, like this is totally fine, but what if we needed to output this several times in our JSX? Every time we outputted this, it would run that expensive calculation. So what we do is there's a function called createMemo that will only run the function once depending on the signal inputs. And that makes this faster. Oh, forgot to get the dependency array. No, just kidding. No dependency arrays in Solid. All right, let's talk about flow control. And what flow control means in Solid is how you structure your JSX. So Solid has this show component. In React, it's common. This is a common way to, depending on data, show different parts, different pieces of JSX. And we normally do this with these ternaries. I remember the first time I saw this syntax, I thought this was quite disgusting, but now I write this code every day, and it just seems normal to me. So in Solid, this is totally valid. This will work just fine, but they have this nice little syntax sugar of the show where we can wrap this in a show and put our win predicate in there, and then move our else to a fallback function. And I think this looks pretty nice. For when you need lots of else ifs, there's a switch thing. So this is what it would look like in React. And in Solid, you can wrap this whole thing in a switch and then have these match clauses with different predicates, and your else goes in a fallback. OK, what about looping? Well, in React, the way we do this, because it's just JavaScript, is we use the array.map to convert our data into a JSX array. And again, this is also fine in Solid. But, oops, we forgot our key prop. Because in React, you need this key prop in order to tell React which piece of data this DOM element corresponds to. So if you resort your data, rather than create new DOM elements, it can actually move those same DOM elements, which is a lot faster because the create DOM is very expensive. In Solid, we just wrap this in a for, and because signals are so amazing, it knows this. It knows what applies to what, so you don't need any key props. All right, error boundaries. So in React, the React docs very kindly provide us with this source code for, I think it's the last class component in all of the React docs. And their instructions are copy and paste this into every single one of your React projects. OK, fine. Solid is like, we implemented that. Here, just import it and use it. I don't know what React is doing. The style prop is extremely similar in both of them. In React, you use lower camel case keys, and for certain things, you don't need to specify the pixel unit, like margin and padding and things. In Solid, it's very similar, except you actually have to use the kebab case for the keys, and you have to specify the pixels. And if you think about it, this is closer to CSS, so it's like kind of better. The class prop, I've been building stuff in React for so long that I've sort of forgotten that class name is not actual HTML. In Solid, they just use class, which is like what HTML does. So there's this special prop called class list. In React, this is a very common pattern, especially if you use like Tailwind or something, where you have a class name, see, I'm saying class name. You have a class that you want on the div always, and then depending on your state, you may or may not want another one. One workaround here is to use, I mean, this is disgusting. One thing you can do is you can use Jed Watson's class name library, and that provides this nice syntax where you can give the classes that you want on everything, and then you can provide this object where the key is the class that will be applied to the div if the value is truthy. This is very nice. I recommend using it in React. In Solid, they just provide this functionality in the class list. The class list is that same sort of object that will do that for you. So if we compare the default way of doing things, I don't know, I think Solid is a little nicer. Okay, lifecycle methods. What do you, to run something when a component mounts and when it unmounts? In React, of course, we use useEffect, and we return the thing that we want to run when it unmounts. And we got to remember the damn dependency array. In Solid, you can just, there are these functions provided called onmount, and onCleanup. And you can call these as many times as you want. And it might seem weird to be registering all these all the time, but remember, this component function is only called once, so it's really only happening once that you're registering these. And again, no dependency array needed. So let's go through a quick little lightning round of other bits that you need to know. Some of them are going to feel very familiar. There's a context API that using create context that is pretty much identical to React. There are lazy components, there's suspense, there's this use query-like thing for fetching and caching data. There's an immer-like mutation API that you can use. There's a Next.js application framework with the brilliant name of Solid Start, and it handles routing and all your SS acronyms that you could possibly want. Some of the less familiar API bits are, there's a way to do nested reactivity using create store. You create a store, and then rather than having individual signals, you can have like an array of signals or an object full of signals, and there's a way to update that and loop through that is efficient and clever. You can do batch updates with a batch function. Normally, every time you call a setter on a signal, that is actually going to go and update the DOM. So if you want to update several things at once, you can do that in a batch, and then it will flush all those DOM updates out. There's this clever thing called directives using these a special kind of prop called a use prop. And if you want to learn a little bit more about that, I have a blog post, if you Google solid final form, where I was able to connect inputs to my final form library only by putting this use field on the input. It gives you direct access to the DOM elements to do stuff with it. Okay, quick footgun recap. Remember, signal values are getter functions. The component function is only called once. You should only call signal getters in the JSX or in other derived signals. Never call a getter before the return. And the corollary of that is never destructure your props. And just for good measure, I've added 5, 6, and 7. Let's talk a little bit about performance. React, when it first came out, I remember it was just so mind-blowing that you could re-render everything on whenever anything changed, and it was fast enough to do that diffing and update the DOM, and it just worked. It was fast enough. But if you've used React for very long, with a big enough application, eventually you run into issues where rendering becomes sort of a problem. Well, why is this re-rendering? Do we need to memorize this? Are we memoizing too many things? Like, there's a whole dev tool based just on figuring this crap out. Whereas over in solid land, the term re-render literally has no meaning, because with every change of a signal, solid goes and surgically updates only the DOM that needs to change, which is what makes solid so fast. You can go to the solid website and dig into these benchmarks, but it's pretty impressive what you can do with signals. So, in conclusion, React is the well-known incumbent with its well-known strengths and weaknesses. And that means that if you're having a problem, probably someone else had it before you, and there's a Stack Overflow question about it, or there's a library that implements whatever it is you're trying to do, like a date picker or something. Or the more modern version of that is the AI models have trained on a lot of React data. So you can just ask them, and it will probably cough up a component for you. Also, if you're wanting to grow your project quickly, it's a lot easier to hire developers for the ubiquitous incumbent frameworks. Solid, on the other hand, is a relative newcomer that benefits from much of what was learned in the past decade, but it's a little too early to know exactly what the weaknesses of Solid will end up being. And I highly encourage you to learn other languages and other frameworks, just to dabble in them a little bit, because they will flip how your mental model of things work, and it will make you a better programmer in whatever language you're actually doing for your day job. So I highly recommend that you all try a little side project and dabble a little bit in Solid, because it's pretty cool. So thank you very much.